Okay, so section 9.3 is over special products of polynomials. With special products of polynomials, you just need to be aware that you don't have to use the shortcuts that I'm about to tell you about, that you can always multiply these out the long way. When we see that we have a quantity squared, we need to recognize the fact that that means to take the quantity times itself. Never, ever attempt to superpower a sum or a difference. Sums and differences have to be FOILed or multiplied or superFOILed. Okay? They cannot be superpowered. A sum or a difference may not be superpowered. So that x plus 3, the quantity squared, is never equal to x squared plus 9. Because this 3x and the second 3x gets lost when that happens. Now, hopefully as you were doing these, and remember you could use whatever method, hopefully as you were doing these and working through them, that you started to say, well, 3x and 3x, 35x and 35x, 2x and 2x, I get this duplication. And that duplication is what allows us to use a shortcut. That whenever we have a sum being squared, we can take the first term and square it. To get the middle, because it's an addition, we'll do an addition sign, and then we'll do a times b times 2. So we can write it as 2ab, 2 times a times b. If we had a subtraction, then we would know that we would have a subtraction in the middle, and then we would do 2 times a times b, which is what ends up with that negative, because that b value is negative. So we end up with a negative 2ab. And then finally that constant times itself, or the second term of the binomial being squared at the end. So that in practice it looks like this. Oh, it's a quantity squared. I know that that means 3x minus 2 times 3x minus 2, but I can take a shortcut to doing that problem. I can say 9x squared minus 3x times 2 is 6x, and 2 of them, so 6x times 2 would be 12x. And then finally, negative 2 times negative 2 would give us positive 4. And you're finished. That's all you need to do those problems. Let's try one more. Actually, I'll leave this easy number 5 for you to try on your own, and I'll work through number 6 with you. So we apply the shortcut again. We take the first term and we square it. 4a times 4a is 16a squared. It's a subtraction, so we'll know it'll be minus. Then we do 4a times 3b, that's 12ab, times 2, so 24ab. And finally, we do 3b squared. So we need to do 3b times 3b, which is going to give us plus 9b squared. Make sure you try number 5. If you pause the video and then come back and check your work. Plus 16. Excellent. So now let's talk about the second situation. Again, I asked you in class to go through and start working through those problems and multiply them long ways. If you didn't, pause the video and do it now. I really feel that if you do the exploration, that these shortcuts will stick better for you, because you'll say, this seems silly, and you'll see the shortcut. I just need to reinforce it with my video, as opposed to me just telling you the shortcut. So take a second and give them a try. All right, assuming you've done this, that we're looking at the fact that what happens if we have a sum times its matching difference? So a problem like x plus 2 times x minus 2. Hopefully when you did these multiplications, you notice that they always, those middle terms, the O and the I of FOIL, if you will, that they always added to 0. They always dropped out. Be really careful with number 9. Make sure that you did this one carefully, that you ended up with a negative x squared, that you didn't attempt to reverse these. Keep the quantities just the way they are. So that when we end up with a difference of perfect squares, when we end up with this problem where we have matching quantities, one being a sum, one being a difference, we're going to end up with a difference of perfect squares. And the shortcut really is that easy, that when you look at it, you say, oh, 3x plus 2, 3x minus 2, they're conjugates, meaning 1 plus, 1 minus. And if they're conjugates, then when I multiply them, I get the middle, the O and the I, are exactly the same, one positive, one negative, so they add to 0, and I don't have to do it. So 3x times 3x is 9x squared. 3x times negative 2. 2 times 3x, those guys make a 0. So finish with positive 2 times negative 2, so negative 4. And that's your final answer. Let's do number 11 together. We're looking at the problem. 2x minus y, 2x plus y. Oh wait, they're the same. One's a difference, one's a sum. That's fine. It means that the middle terms, the O and the I, are going to drop out when I multiply. So I simply need to do 2x times 2x, that's 4x squared, positive 2xy, negative 2xy, there's the 0. Negative y times positive y gives us minus y squared. And that piece is finished. Try number 12. Pause the video and give it a try. So again, a reminder that this shortcut is never one you have to use. It's one you're allowed to use. Be very careful that you make an observation before you attempt to use a shortcut. There are lots of mistakes that get made simply because the shortcut wasn't used properly. Now, let's go down below here to these last 3 problems. I want you to notice right away that this is a sum with an exponent that's not squared. Because it's telling us to do x plus 1, the quantity cubed, we cannot even use the shortcuts we just talked about. We need to take that as x plus 1 times x plus 1 times x plus 1. Because of the way this works, we can multiply these 2 numbers together first. And look, they're exactly the same. So I can use my squared shortcut. So I'm going to keep this first quantity as x plus 1. And the second quantity, I'm going to apply my shortcut. They're exactly the same. So we do the first term squared. It's an addition. 2 times the first times the second term. So that's going to give me 2 times 1x, so 2x. And then the second term squared. 1 times 1 is 1. So I've done this multiplication. Now I have a binomial times a trinomial, and I can finish this problem. When we do a binomial times a trinomial, remember using a box is going to make life a little easier for us. Go ahead and try number 14 and number 15, and we'll talk about them in class.